Okay, fine. I'm starting inorganic and physical chemistry 2. Under that, the unit 3. So this contains two chapters. One is thermodynamics and the other one is surface chemistry. Now I will start with the surface chemistry. If we are looking at the content of the surface chemistry, it contains adsorption and catalysis. So under adsorption, we will come to know what is adsorption, types of adsorption, and then types of adsorption isotherm, Freundlich adsorption isotherm, and its limitation, Langmuir adsorption and its limitation, and BET equation. And then application of adsorption. Then we'll move to the catalysis. What is catalysis? Its role in unimolecular, bimolecular, and more particularly types of catalysis. There are two types, homo and hetero catalysis. Mechanism also we are discussing under the catalysis. That's called homo as intermediate compound theory, adsorption theory, and acid-base catalysis theory, and also enzymatic catalysis and its mechanism. Enzymatic catalysis and its mechanism is called Michaelis-Menten mechanism. Heterogeneous catalysis, and here heterogeneous means catalyst and reactants are in a different phase. So that means one will be in aqueous media, another one will be in organic media. So that means two phases will be there. Such reactions are called heterogeneous catalysis. More particularly, catalyst will be in the solid one and the reactant will be in the aqueous, means organic liquid one. Such reactions are called heterogeneous reactions. Homogeneous reactions means both the catalyst and reactant are in the same phase. We will also discuss about what are unimolecular and its mechanism, bimolecular surface reactions and its mechanism, autocatalysis. So autocatalysis means here catalyst is not used, but one of the intermediate will act as a catalyst. Such type of reactions are called autocatalysis reactions. We will also look into the applications, more particularly applications of use of catalyst and its applications. And we are also discussing about this concept used in the removal of unwanted compounds from the industrial waste, and also its application in the purification of water. One also we are discussing in this chapter. So with this, I will go to the adsorption. So adsorption means the phenomenon of concentration or assimilation of the gas or liquid at the surface of the solid or liquid with which it is close proximity or contact is called adsorption. That means adsorption is a surface phenomena. So that means there is a reaction of surface of the one substance with the compound of the substrate. Here you need to remember what is substrate, what is adsorbate, what is adsorbent. Absorbent will be usually a large surface area one, and adsorbate will be the one which is accumulate on the other surface. So that means the material providing the surface upon which adsorption occurs or takes place is known as adsorbate. Let us consider here the few examples are there. Adsorption of gas by charcoal. In this, charcoal will as an adsorbent and gas will act as an adsorbate. Similarly, adsorption of dye by charcoal. Dye means that may be a colored compound. This colored compound can be removed by charcoal. So that means colored compound or dye or methylene blue will act as an adsorbate, and charcoal will be the adsorbate. So similarly, this adsorption technique is used in the purification of the raw sugar. Raw sugar means crude sugar. Crude sugar will have a creamy color, cream or brown color, little light brown color. That light brown color can be converted into white crystalline sugar by passing the dissolved solution of crude sugar through a charcoal bed. Charcoal absorbs all the colored, and then obtained one will be the crystalline colorless sugar moieties. This adsorption technique is also used in the removal of moisture from the air. That means if you want to purify air from the moisture, we can use a silica gel as the adsorbent. So silica gel removes the moisture present in a air in the room or uh, other space. I'm taking few more examples. This example itself is a little elaborated here. So here, accumulation of the dust on our skin when we travel in regions of the heavy traffic. So in this one, person will act as an adsorbent, and skin will act as an adsorbent, and dust particle will act as an adsorbent. Then adsorption of the dye like methylene blue by charcoal. That means charcoal will act as an adsorbent. Methylene blue will act as an adsorbent. Protection from the poisonous gas. More particularly, in the mining area, a special masks are provided. That those masks contain charcoal. Uh, these charcoal absorbs the poisonous gas which are entering. Then a solution of raw sugar. You can observe that this is the brown brown colored one. That means crude one or raw sugar. This can be converted into a crystalline white by passing through a bed of animal charcoal. So what is the difference between wood charcoal and animal charcoal? So animal charcoal means this is the charcoal obtained on burning animal. Similarly, wood charcoal means charcoal obtained on burning wood. So air becomes dry in the presence of silica gel. Then here I am taking few more examples. Adsorption. Uh, there is a difference between the adsorption and absorption. So absorption means here the substance is uniformly distributed throughout the bulk of the solid. For example, sponge in contact with the water. So that means water penetrate into the sponge. That means water is present throughout the sponge uniformly. One more example is gulab jamun. Here also sugar moieties are present throughout the sample, and the chalk in water. So water is present, penetrate into a chalk. That means water is uniformly distributed. And then rusk or biscuit in sugar. This is also an example of absorption. Then adsorption means it's only a surface phenomena. That means it is present on the surface and it won't penetrate into a compound. This is an example of absorption. This is an example of adsorption. So this is again silica gel. It is used to purify the air. And charcoal also is used to remove colored compound. With this, I will go to the next. Here I am taking few terminologies. What is adsorption? What is adsorbate? What is adsorbent? And desorption? And then absorption. So adsorption, as I mentioned earlier, accumulation of the molecular species at the surface rather than the bulk of the solid or a liquid is termed as a adsorption. Adsorbate means the substance which is being adsorbed on the surface of the another substance is called adsorbate. Adsorbent means this is the substance present in bulk on the surface of which adsorption is taking place is called adsorbent. Desorption means the process of removing adsorbed substances. The process of removing adsorbed substances from a surface on which it is adsorbed is called desorption. Absorption means it is a phenomena in which substance is uniformly distributed all over the surface, and this is called absorption. Absorption means when the adsorption and absorption takes place simultaneously, then it is called sorption. So any of the one term or two term can ask for 2 marks question in a examination. So here I am taking few more examples. Molecules adhere to the surface of the material. This is again adsorption. And here molecules are drawn into the material. This is again absorption. If we are looking at these two, this is an example for adsorption and this is the absorption. Here molecule or substance are present throughout the sample, and here adsorbate is present on the surface of the adsorbent. We are looking at the solids will act as a mainly finely divided state. That means finely divided powder can act as an adsorbent, very good adsorbent. For example, silica gel, charcoal, surfactants, even colloids can act as an adsorbent. Here I am taking few more examples of adsorbent. Cotton will act as a adsorbent when removing water on a floor. Similarly, adsorbent pulps also available can act as an adsorbent. And granular industrial adsorbents are also available. Adsorbent polymers also available can act as an adsorbent. Few more I am taking here. So here alumina means neutral alumina or even creams can act as a adsorbent. Earth, Fuller's earth can act as an adsorbent. This is the charcoal, activated charcoal. There is a difference between charcoal and activated charcoal. If the sites means active sites, normally catalyst means active sites one will be the better compared to the non-activated. More particularly, activation is done for the charcoal. Activation means there are many kinds. One is treating with acid, another one is treating with base, one more is treating or heating. By doing so, it is possible to activate. Anyway, I am taking activation one in a later stage. So this also will act as an adsorbent. So here I am taking the difference between the bulk means absorption and adsorption mechanism for surface phenomena. So here there are two types of molecule. Bulk molecule means absorption. Surface molecule means adsorption. Surface molecules have a different environment than the bulk molecule because the bulk molecule, when it is when we are taking water and gas system, the bulk molecule will have a surrounded by a symmetrical force of attraction, whereas in the surface molecule, it will have a different atmosphere, imbalanced force of attraction will be there. So this makes the difference between the mechanism when it compared to the bulk molecule. Bulk molecules imbalance. Okay, here is the imbalance. This here the bulk molecules are uniform. That means other moieties of the, for example, water moieties are surrounded by the bulk moiety. But here, suppose gases are completely soluble, then it's a different thing. If the gases are partially soluble, then there is an existence of surface phenomena. There are gases completely soluble. For example, ammonia is soluble in water. So with ammonia will act as a bulk moiety. That means absorption. With chlorine or some other thing, that will be partially or less soluble in water. In such case, adsorption surface phenomena is exists. Overall, you can remember that in bulk moiety, symmetrical force of attraction will be there between the adsorbate and adsorbent. Here, unsymmetrical force of attraction between the adsorbate and adsorbent. This makes the difference between the mechanism of the surface adsorption and absorption surface mechanism. Then here I am taking continuation. When such unbalanced force, adsorption comes in contact with other species, they have a tendency to attract the other species of at their surface. As these molecules remain only at the surface and do not go deeper into the bulk, their concentration is more at the surface than the bulk of the solid, which is termed as adsorption. So here
Just absorbing
on the surface,
and going inside the molecule.
correct. That's called adsorption mechanism. If we are looking at the thermodynamically feasibility, and this adsorption mechanism also follows a thermodynamically favored one because free energy is negative. So when free energy is negative, free energy is less than zero, that means negative. T delta S is greater than zero, that means spontaneous process. Therefore, enthalpy change is less than zero, hence absorption is exothermic reaction. And here heat is liberated. This heat is called heat of adsorption. And adsorptions are of two types. One is physical adsorption, another one is chemical adsorption based on the interaction between the adsorbate and adsorbent. So in the physical adsorption, the force of attraction between the adsorbate and adsorbent is of van der Waals force of attraction. Whereas in the chemical adsorption, the force of attraction between the adsorbate and adsorbent is the chemical force of attraction or both chemical adsorption, yes, both of them are surface level. Completely we are talking about adsorption only. Just we mentioned what is absorption. So absorption means the material or substance or molecule is present uniformly throughout the compound. We are only differentiating what is adsorption, what is absorption. But yes, it is possible. And again, several factors also possible. Those factors we are taking in the next few slides. So here I am taking the difference between the physical physisorption and chemisorption, or physical adsorption or chemical adsorption. In the physical adsorption, weak van der Waals force of attractions are involved between the adsorbate and adsorbent. Chemical bonds or chemical force are involved in between the adsorbate and adsorbent. Here, low heat of adsorption with respect to physical adsorption, high heat of adsorption with respect to chemical adsorption. Multi-layer is possible physical adsorption. Only monolayer is possible with the chemical adsorption. Adsorption occurs at low temperature. That means physical adsorption requires low temperature. Chemical adsorption requires high temperature. Why means chemical adsorption means requires a bond formation. Bond formation, and you know that rate of reaction increases every 10 degrees. That is the principle involved in the chemical adsorption.
Chemical bonds.
Weak bond are involved. Yes, yes. Then the rate of adsorption increases with increase in pressure. Van der Waals of force of attraction, it is only in the physical adsorption. Better means stronger than the van der Waals force of attractions are involved in chemical adsorption. Rate of adsorption increases with increase in pressure with respect to physical adsorption. Rate of adsorption decreases with increase in pressure with respect to chemical adsorption. So let's look into the what are the factors affects the adsorption.
So why you mentioned the first year for chemical absorption?
In the previous one here.
Yes.
Okay. So
Pressure is directly it increases directly increases pressure.
the rate of adsorption increases with increasing pressure. And again, here we have to consider, sir, so this is applicable if the adsorbent is gas. Okay, rate of adsorption increases with increase in pressure, applicable only if the adsorbent is gas. Okay, then rate of adsorption decreases with increase in pressure. Rate of adsorption decreases with increase in pressure. And you know that, suppose let us take gaseous molecule and then the solid. Suppose gaseous molecules are sitting on the solid. So up to what time gaseous molecule sits? It's based on the number of active sites. Once the active sites are filled, irrespective of the increase of the pressure, rate of adsorption won't increase.
So basically absorption is directly dependent on number of active sites, right?
Correct.
Because pressure is not a factor which will affect the presence of active sites.
Correct.
It doesn't not mean.
Correct. Correct. You are right. Okay. So now I will take the factors affecting the adsorption. Nature and surface area of the adsorbent. That means nature of the adsorbent. Adsorbent may be a solid or liquid or gas. Usually, adsorption depends on the surface area. Surface area means no more surface area. For example, solids, let us consider charcoal will have a more solid surface. And overall, if the surface area is more, then adsorption is increases. Nature of the gas. For example, if the gases are soluble in water and the liquefiable gases. So in these two cases, adsorption increases if the liquefiable gases are used, if the gas is soluble in water. Then temperature. Temperature is inversely proportional. So that means temperature increases, adsorption decreases.
And uniformity is slow.
Yeah, that I'm taking details in the next slide. Then the pressure one, in the case of pressure, suppose adsorbate is the gaseous molecule. In such case, initially there is an increase of adsorption. That's because of the active sites. If the gas molecule sits on all the active sites present on the adsorbent, then irrespective of the increase of pressure, adsorption won't increases. Then reversible nature. So that means it is possible to reversible nature means you know that equilibrium, conversion of product into reactant. So suppose if we are remove means decreasing the pressure, then what will happen? Adsorption decreases. So this adsorption decreases means is nothing but a desorption. So in the reversible nature, desorption, adsorption, equilibrium condition with respect to the pressure. Then exothermic nature. Adsorption is an exothermic reaction. Here heat is liberated. That heat we will call it as a heat of adsorption. Specific nature. For example, coal gas and ethylene gas is used as a adsorbate. In such case, the adsorbent selectively allows one of the gas to adsorb on a surface. That selectivity also possible. Now let's look into the detail about all these factors. So nature of the and the surface area of the adsorbent. As the adsorption takes place on the surface of the substance, hence extent of adsorption is directly proportional to the surface area of the adsorbent for a given mass. The extent of adsorption can be increased by activating the adsorbent. Yes, active cell. And can be achieved by making their surface rough. by the mechanical rubbing or chemical action and the removal of volatile impurities or the other process.
That's why we rub the.
Yes, to increase the active sites on the surface of the adsorbent. Wood, for example, wood charcoal is activated by heating between 350 degrees centigrade to 1000 degrees centigrade. Hence, free surface are made available for the adsorption. Nature of the gas. The gases which are easily liquefied. So easily liquefied means will have high critical temperature and highly soluble in water or adsorb to a greater extent. Temperature, extent of adsorption varies inversely. Extent of adsorption varies inversely. That means adsorption is inversely proportional to the temperature. Lower the temperature, higher will be the adsorption. Then factors affecting the adsorption. Pressure. If the adsorbate is a gas, then adsorption increases with the pressure of the gas. However, once the active sites are occupied by gas, the further increase in pressure has a little or no effect on amount of gas adsorbed. Reversible nature. The equilibrium of the adsorption is strongly affected by the temperature. So with respect to pressure, we are taking adsorbate as a gas molecule. Then with respect to reversible nature, we are taking temperature. The equilibrium of the adsorption is strongly affected by the temperature. That means the adsorbed gas can be removed by increase in temperature and decrease in pressure. This removal of adsorbate from the surface of the adsorbent is called desorption. Then exothermic nature. Adsorption undergoes exothermic process. Adsorption undergoes exothermic process and the heat of evolved in the adsorption is called heat of adsorption. Specific nature. That means adsorption of gases by solids by selective. For example, from the mixture of ethylene and coal gas, charcoal adsorbs ethylene only. Selectivity. Then, okay. So you know that adsorption isotherm. Adsorption isotherm means study of adsorption through graphs. Study of adsorption through graphs is called adsorption isotherm. These are of three types: Freundlich adsorption isotherm, Langmuir adsorption isotherm, and again Freundlich adsorption isotherm is the normal one. Langmuir adsorption isotherm is for the monolayer one. Bronner, Emmett, Teller, PET theory for multi-layer adsorption isotherm. So let's take the first one, Freundlich adsorption isotherm. So here is the definition. It is the curve. That means this is the one. It is the curve obtained by plotting a graph of amount of substance adsorbed. That means X. X is the adsorbate. Adsorbed on the mass of the adsorbent. M is the mass adsorbent against the equilibrium. This is the saturation point of the pressure or concentration of the constant temperature is called adsorption isotherm. So overall, you can remember that X upon M is equal to K into saturation pressure. What it means? X upon M. What is X? Adsorbate. So amount of adsorbate adsorbed on the adsorbent, mass of the adsorbent. And it is observed that as we increase the pressure, it is observed that absorption increases. Once the saturation point is obtained, then adsorption does not change. That means independent the pressure. That means this is because active sites are occupied by the gas molecules. Then there are no active sites. That's the reason, irrespective of the increase of the pressure, adsorption shows independent of the adsorption. Linear means constant.
So why doesn't it decrease?
The go down means you have to remove no
So it
active
stays in same.
saturated means no increase or no decrease. Okay, so here suppose a 4 marks question is framed on this, write Freundlich adsorption isotherm. What are its limitations? So Freundlich adsorption isotherm is an empirical equation which states that at constant temperature, x upon m is equal to k into p to the power of 1 of n. Here, x is equal to amount of adsorbed on the mass of the adsorbent. K is the equilibrium constant, distribution constant, and P will be the equilibrium pressure. And 1 upon n, here K and N are the constants, which depends on the nature of the adsorbent and gas at a particular temperature. Right. So if we are looking at the limitations, experimentally, it was determined that extent of adsorption varies directly with the pressure till the saturation pressure is reached.
So you did not explain that.
Yes, limitations, only 2 marks question. This is 2 mark and adsorption, Freundlich adsorption 2 marks, 2 plus 2. So 4 marks.
That same statement.
Yes. Why? Because this is examination point. That's for the concept based. Okay. Usually this question is framed for the in keeping mind of the below average student. Right. Then experimentally it was determined that extent of adsorption varies directly with the pressure till saturation pressure is reached. Behind that point, there is no adsorption even after applying higher pressure. Hence, Freundlich adsorption isotherm failed at high pressure. Right.
Even the graph of they showed the same thing also. Graph was uniform, showed the constant.
This is constant
Yeah.
after saturation point.
Yes, sir.
After saturation point is constant because there are no active sites. Okay, that's the reason there is no increase of adsorption.
That this graph was done after the experimental analysis.
Yes,
Ah.
see, look here. So, for example, you consider that here 1 gram, okay? X upon 1 is 1%. Then X upon M is 2%. Here 1 pressure, 2 pressure, 3 pressure. So at 1 pressure, 2 pressure, 3 pressure, adsorption increases. Once it reaches the saturation point. What is the saturation point? Once the active sites present on the adsorbent are filled with the gas. Then whatever the amount of the pressure you are putting, it's of no use. That means independent. Adsorption is independent after the saturation point. That's called PS. Suppose if you are taking a gaseous one, previous one is the gaseous one. If we are taking a solute, then we can express them in terms of concentration. X upon m is equal to k into c to the power of 1 upon n. This equation is 2. What is equation 1? Equation 1 is x upon 1 m is equal to p into c to the power of 1 upon n. That is with respect to gaseous. This one is with respect to solute and solution. Here, C will be the equilibrium concentration of the adsorbed substance in the solution, and X is equal to mass of the solute adsorbed. Then the equation 1 may be 1 means X upon M is equal to gas. May be tested graphically the following way. The shape of the curve is parabolic. This is the parabolic. So here X upon M is equal to Kp. X upon m is equal to k into p into 1 upon n. Then x upon m is equal to k. So here what we can learn? We can learn that at low pressure, adsorption increases rapidly. At intermediate pressure, adsorption increases slowly. At high pressure, adsorption remains constant. It is possible to verify this Freundlich isotherm by taking the logarithm of both the sides, equation 1. then log of x upon m is equal to 1 upon n into log of p plus log of k. Then plot the graph log of x upon m versus the log of p. Then it is obtained that the slope is 1 upon m, and it's also a intercept. The intercept is equal to log of k. This is how the verification of the adsorption isotherm. Then let's look into the one more theory that's called Langmuir adsorption isotherm. Here, the postulates the surface is homogeneous, so uniform. Then all the sides are equivalent. Means all the active sides are equivalent. It's an assumption by the Langmuir. Then monolayer adsorption only, one layer only. No interaction between the adsorbate and adsorbate. That means whatever the adsorbed molecule, no interaction. That's yes. That is the first layer. Then heat of adsorption is constant and equivalent for all the sites. Correct. These are the assumptions. Then, so this is again somewhere around 1920.
Sorry, 1980.
Yes. Then adsorbate molecules have a tendency to get adsorb and desorb from the surface. That means adsorption, desorption. Both the things is possible. Reversible nature. These are the postulates of Langmuir adsorption isotherm. So next I am taking the derivation for the Langmuir adsorption theory. Here I am taking A is a gas one, means adsorbate, and B is the adsorbent, and it will be in equilibrium, adsorption, desorption. When these two are adsorbed, AB will be the adsorbed molecule. When this is desorbed,